Hello, welcome back to another video where we're working on build your own Git in C for Codecrafters. And the way I'm doing it is I'm doing things a little bit more difficult, I guess. So in essence, we're up to the stage where we're just doing a cat file, which usually would just display a file, display a blob type thing that's in your Git object storage. And so how it does it is you get it from a directory, then the hashes kind of split it into a folder after 2 bytes. And so we got that, and then in this, we has a header and the contents of the blob, which should look like this, but it is compressed using zlib, which is also potentially described in here somewhere. Apologies for the display. So what I had been doing was kind of walking through the so I can see what Git has produced, like the actual Git software has produced a particular blob, and it has the particular value in hex out of it, and so we could reproduce this by git cat file this and see that, and the binary of it is this split up into all the bytes like this. And so the first thing we do is kind of get 2 bytes. We get 2 bytes, this is them. The first 4 should be set to 8, meaning it's deflate, and then this says the window size is 32k, which is like up to the spec really. And in essence, this is only really defined for cm equals 8. Everything is cm8 and not defined for not cm8. So then we look at the flags and basically see that all the important ones are that, and we make sure that the flag check works. So the rest of this is deflate encrypted stuff. No, that's alright. Deflate encrypted stuff. It's kind of like bling for a bit. And in this, we kind of go bit by bit. So that's defined in another specification, the RFC 1951, and so it kind of describes it. And I've watched like a few videos on this kind of format, because deflate is also used by stuff like PNG and maybe just that, I don't know. But yeah, in essence, when you're reading the bits, if you're packing it into data, then it is least significant first. But if it is a Huffman code, which is important because that's what hopefully we'll get to today, it should be the most significant bit. Which, yeah, I don't know. So far we've kind of gone through, and it kind of gives a bit of background. But yeah, each block format kind of looks like this. So here we'll get this value to get 1, and then we'll get these 2 values, but in that order. So really this is not a fixed Huffman. Golly, I've just switched from the other keyboard. Dynamic. I can't remember what I put that there for. I that will just check that these look right. So after that, then we get 10010, yeah, and 01010, yep, and then 0111. So that puts us at that point there. I could almost give a little thing. So what happens now is we read some stuff. So we now read, yeah, so this these ones are the ones that are kind of there, and this is when we have a dynamic Huffman code where the B type is 10. So what we do is we're going to loop a bunch of times, and it's HC len, so we should be looping. I kind of want to do some like the magic. Maybe we can do it down here. So this is like our bit stream. Yeah, this is our bit stream, and what I want to do is for each one, can we do a just on that? Cool. That does that. Cool. So, apologies. And hello. And I believe we were just back here, so I'll just get into it. So it was the 11011. So what I was wanting to do was make a vmacro, and I was going to select the line, then reverse that, and then go down one, and then close that, and then if we did 13 and of that macro, we should swap all the bits. It didn't do this one, but we can do that, and then we can kind of just join these all up, and this can be our bit stream. And I'll see if I have kind of got that right. So the first one, have we already read this one? Yeah, so that's just that first one. So we've read kind of all the way up to there. So they can, I guess, all go to that. I guess maybe I want to replace the spaces with nothing, and do that everywhere, and then just search for some garbage. So what I kind of want to do is get all of that. So yeah, that's kind of meeting that. I actually wonder if I want to just delete it, and we'll call it that. And that way we can kind of see we have a thing of 3, and now these were constructing codes, so I guess they're to go on the other order. It doesn't matter for this one, but that means that we should have it. So I do note that these are kind of off by one. Yeah, we swallowed off a extra 0. So if we get that. So now we can probably do maybe another little thing. And 3 across and then enter. And if we undo that. And so we wanted to do it actually len plus 4, so we had actually len. So we want to do this 19 times. So if we do 19 and that macro there, oh, that undo that. So alright, so 3 across. Right. Now if we do this, 19 times? 19 of that macro there. And so that should spit us out 19 things. And we can kind of say what this is, and we can potentially take that, just because they do it in kind of a weird order. Maybe something like that. And so now we can kind of see what the remainder is. But I think these are meant to be reversed. So I wonder if I can do that. Nah, it just does the whole line. But what I can do, we'll continue on and just see how many things we have. Well, so it's encoded using the code length, using this code length table. So that's just using this thing. Is that what I'm kind of getting? And we can only get a number up to, well, with 3 digits we can get more than, yeah, so it's a 0 to 7. Right, so some of them are kind of valid, but I mean, that value there is only 7. So it means the length is, you can never get up to like any of these juicier ones. First the literal length code and then the distance code. each of those codes is described I just don't quite get it. Because at this value here, 3.2.2, it does kind of describe some things, but I mean this is right. So we can kind of do this. I'm wondering whether I start kind of constructing this a little different. Maybe if I do zlib.c, and we kind of need to get some data anyway. And so I believe the place I was getting this data from was so in head of a.10 was in this blob here. So maybe if I get this one, so cat get objects, and if we get 7, 8, and so this thing exists, and that has these bytes coming out of it. So what I think I might do is just kind of grab that all by itself and zlib, and this will say char object file, and this can equal to that, and then we'll get file, and this can be open of object file, and maybe we'll get it read byte mode. Is that what we need to do? Text file, but we want alright, it's just that's there for good luck, but yeah. So this could potentially fail, but maybe we'll we can do something like this. And so now what I want to do is kind of just do a zlib decompress of file, but maybe I kind of want to like if read the whole thing. So we need to do like a if seek. So we want to do that from file, and the offset is 0, 0, L, and seek end, and then we can do a long size equals f tel of file, and then we can probably do an fseek. Seek, what was the other one? Seek set. And so then we can probably get we can get some bytes. So this can be malloc of size, and if data equal null, we can do a few things. We can close file, and we can return 2 maybe. Maybe just something a little different. And then we can do an fread. And what that have, so we give it the data, then we say how big it is and how many things we want to do. It's kind of like a weird way of doing it. We could not use the file pointer and just use the file descriptor. That might be a cleaner way of doing it, but for now we can do something like this. And what was the last one? Just the file that we're reading it from, and this is going to return us the thing and number of items read. So yeah, we just want to make sure it's not so if this is if it's not equal to 1, then that's kind of the error case, and we can close that, and maybe we can just return 1 in all these cases. This can also do like a thing, return, it kind of just says that we so if this b equals -1, then we can close the file and return 1. I almost want to do a little trick. Ret equals 0, and we can do a define return. Oh, can we do like curse thing like that? I think we can. Defer is maybe more what I want to do, and we can say and this is just going to do, in fact it can do a do, and it can set rec to be equal to code, and then we can just go to defer, and we can do this while 0, which just means do it forever, and so here we can probably do an define undef return defer, and maybe put this here, and we can make this defer, and this can be if file, and that kind of means that we maybe do something like this. And we can do stuff like that. and they'll just do the thing. And potentially I can do another one, and we can have like an expect. Can we do stuff like this? And the thing that I want to do is I want to expect expression to be true. Yeah. So this can just kind of be if expr and maybe do an if not expr. Then we can return defer 1. And then here we can go expect file not equal null, and that should, it will do like a double negation, but and then we can expect this is not equal to -1. We can have expect size not equal -1 here. I believe that was a potential. Yeah, -1 for that. And make sure that this not equal to -1 as well. I have no idea if this will compile, and we can do that. And maybe find the not. Are we allowed to do that? Oh. Alright, so if we do that, then that'll happen. Perhaps we can def expect as well. And so maybe I want to do set make prg equals gcc minus w all minus w error minus w pedantic and w extra. Is that one of the things I want to do? And maybe I want to also do if sanitize equals address and minus g gdb and minus g, and do something like that, and zlib.c, and then I can kind of see what happens. Alright, so I don't have a bunch of things. There is cool, I haven't done that. Is it not? Now here we want to do something like that. Alright, so now we just have to do one thing. So zlib decompress, and we're probably going to have the data that we have, and maybe we can also pass in the size. And that's probably what we can do. And so this will be the data and the size. We have already read what we needed to do. In fact, we can potentially close the file at this point here. But make sure we set it afterwards. And like this can potentially be a bit unusual. Hard to know. I think I'm just procrastinating with what I actually kind of want to do, which is start with the compression things. So what we want to do, we probably want to do maybe like assert maybe that's size is greater than equal to 2, and so I guess we need an assert h. Had some interesting times with the old nerve. So why do we need two things? It is because we're going to have, I kind of want to say that things include std int.h, and that's kind of what I have, and then we can have what they actually are. So that's a string, that's alright. And here we can int ht. Cool, and so uint 8 p, so the CMF is going to be data at 0, and flag is going to be the next one. Alright, so depending if fdict is set. So how do we get the first thing? CMF is divided into two things. So I guess we can kind of construct these. So this is bits 0 to 3, and how I had it in a.tmp, I just took it as two 4-bit numbers, which is kind of how they have it described. So this is going to be just those lower bits, and info is going to be just the top bit, but then brought back down to earth. So that makes sense. I think that kind of makes sense. Right, so here we probably want to do assert cm equals 8, and just make sure that that is there. And then we probably want to do an assert that info is less than equal to 7. I think I want to just make the assumption that it is equal to 7, which I think in my case it was a.tmp. It was equal to 7, which is like kind of the standard size. Right, so in that case, zlib. In that case, we can probably start making some stuff out of our flags. So, we need to make sure that if like check word, we'll just call this check because this is going to be CMF times 2 plus 6, and I think I want to upcast that to a unit that, and then we can add on a unit. It probably does it for me automatically, but may as well check. So we probably want to do this assert that check is equal is a multiple of 31. Otherwise, we have two things of note, which is fdict, and this is bit 5 of flag. So this we kind of just want to do that. So if it was bit 0, then we would shift it right 0 times, but it's bit 5, so we shift it right 5 times, and then we and the result of that with 0x1, so we only get the 1 bit. And this we want to shift down 6 times, but we also want to do that with 3, and that is f level. And what assumptions do we want to make with fdict? Kind of want to do some assumptions that like these aren't set at the moment. Assert. Maybe I want to do define an implemented and this can be do def we actually have the function name, I think, and so this can be file line and func, or it hasn't liked it. And can we just do abort? Is that like in a thing? While 0, except we don't want that. Right, so and then we can do things like this. Apologies. But we do need to make those assertions, and these are unsigned, and it's perfect. So this is the start of the zlib thing. So at this point here in this stream, I kind of want to make a bit thing. So we've kind of read 2 bytes, but I kind of want to read, make like a bit stream. So we can have something like here. Just check things. It's like alright. People wanting free work. Works hard enough as it is. So what this thing is going to be is maybe like a bit stream. So we're going to have a event HT. This is like our data to come. Event HT. This is going to be our current event HT, and this is probably going to be our index into the current. So what it will right. So we're kind of assuming those things there because it kind of makes sense for that. So we're going to make a bit stream bits, and we can make this equal to so the data we can make it actually data plus 2, and the current it can be equal to data 2, I guess. Nah, I think this isn't kind of what I want. I don't want to have a current. I'm just trying to think of a way to know that I haven't read a byte yet, and I think the best way is to just not have that byte, and I'll just dereference it each time. And so what is this going to do? We're going to maybe just for ease of use, maybe a bit stream at the next, and we can pass in a bit stream. Maybe we'll call it a stream. And so this could, it should either be a 0 or a 1, perfect. But I guess in the error cases, so if stream equals null, or stream data equal null, or do we need a size here? Because we haven't actually passed in a size, and we could have null bytes. So I think long size is required, and so the size will be equal to size minus 2 because we've read 2 bytes. So if that is that, we also need to, if data, then we probably need to do a free on data. I was just thinking, where's this data getting free? So if that is the case, we can return it to, just to, I don't know, signify some error. Or we could even return a good old -1. That's probably all right case. And we could probably also do that. Do we have EOF? Yeah, I'll just return EOF. And EOF is its negative value of type in. Easy. I think that is what I'll return from my bitstream when I get it, because I guess at this point we're at the point where we need to start reading. Where was these are kind of done that? Yeah, details of block format 3.2.3. It's like halfway through the page. I mean, I suppose it's similar to. I don't know. It's pretty interesting. So here we kind of want to now be in the deflect now. Maybe we could even just I mean, zlib decompress, it is probably going to return us some data. Like, how do we know how big to get? That's one thing. Right, so I think we have a few cases in this. So if stream index no, we don't even need to bother with that, but we probably could make an assert that stream index is less than equal to 7, so you can only shift it so much, and we'll basically be returning based on that. So we'll have a rep, and this can be our stream data. Get that first thing, and we want to shift it by the index, and we just want to get 1 byte from it. And here we can do like I'm not a fan of the hiding pluses in. I think because depending on where you put the plus, so here it will be testing if the value the value currently is positive, truthful. Whereas if we did that, then it will be seeing whether the next value is truthy. But yeah, what I'll do is just be a bit more explicit. And I was watching something recently. It would be cool if you could have something, I don't know what the syntax would be, but what I want to do is do index plus plus. Well, actually, no, I think I need to do a bit more logic than that. And I think if we have now gone out of range, we want to stream size minus and stream data plus plus, and then stream index equal to 0, and that's what will happen on that. And do that. So we shouldn't get into any sort of state, and then we can just return the rec, whatever we got to, and it will alter the stream as we go. So back to our bit stream. So I guess I like now want to go deflate, and this is what we're doing deflate wise, and we're taking a bit stream. We're returning some data at some point, don't know when, but for now we will so this is like deflate block. We'll deflate a single block, so this is going to be def I now. So are we on the last one? So how do we get the things again? I called it bit stream next, and we passed it stream, and I wonder if I could pass it. Yeah, I could do something like that. We could have something like this, and we can pass it to, I want 2 bits, and and this is going to take in the same stuff, and we probably want to have like some error cases. If like if we're asking for mutate bits, maybe I could just do an assert. If we do an assert, I kind of want the assert the next layer up, but I'm not too sure how we can do that without making the whole thing macros and whatnot. But maybe that's what I want. Because I want to see what line it is that it kind of went. So because we can't get too many bits, is kind of what I'm thinking. Well, perhaps we could allow us to have heaps, and we can have up to that, and we can just assign that to whatever level that we want. So this can be I mean, can we have like ridiculous long? Nah. But I mean, this is probably suffice. Return rect. So what's happening in this while bits is greater than 0? We want to make sure that we do the bits minus at the end, otherwise we'll be doing this forever. So we want to read a bit. So we want to kind of shift what we currently have up by 1. Yeah, I mean, we can probably make this equal to 1, and we want to OR in the bit stream next of the stream. And probably want to well, I think if next is we can just return ret, but then what if ret hasn't yeah, cool. So if we detect the end of stream, then we will just push that on up. Well, we won't just push that on up. We'll return whatever we currently have. But I guess we have consumed a bunch of stuff. I think I'll just do that. So if we return end of stream, we'll just return it. So, and then this can just be a 0. So we kind of want ret to be equal to, and probably want to assert next, and is that what we do? Who knows where the precedence is? I think I don't need those, but basically what I want to say that like I only have 1 bit. I think that's what it says. So this is going to be ret shifted up by 1 and ORed by next and 0, 1, so we shouldn't have any carrying problems, and it's just going to be that whole thing. Then we're going to subtract 1 off, and this will just continue on, and we'll build up a thing. Cool, so that does that. So I guess at this point here we could kind of see what it kind of looks like. So yes, if printf, maybe just do well, do an if printf sd error. Well, maybe we could do like info and do something fancy like this. So we can say deflating block b final equals d, and b type that was kind of hard to type. I kept on wanting to write bytes, which has like the first it's got a few letters similar, but and I probably type it a bit more. So I kind of want to make that binary, if that's a possibility. I wonder if that is. And we can do something like that and be final and be type. Be type. And we can probably do something like unimplemented there. We haven't gone to the rest of it. And we haven't gone to the rest of that. And deflate, and this was going to be bits, just the pointer to that. I reckon this could do we not have func? See func. Oh, as I wrote it, I realised my folly. Func, we actually want to be lowercase. Is that what it is? Yeah, it is. Right, so info. What are we going to have here? We're going to have an info and a rest, I guess. This is going to print that sort of stuff, and we're just going to let us have, we'll call it a format actually, and we'll do that format, and then we don't need that, and then instead of func we do VA args, except like yeah, so it is fun. Alright, GCC macro token string. Nah, it's not that. Very addict. It wasn't like 2 hashes or 1 hash beforehand. Like, which one do I want? Alright, I think that is what I want. Yeah, do that, and do that. Right, so we can't do B. Can we do? Can we say that we can we just say we're a higher standard? GCC %B print F. When did it come into play? Formatted output. I mean, how do I say that I just have it? It is an error. Ugh. That's a 2x. So if we do C2x, do something like that. I mean, I don't really like it, but cool. And now we have this. So I kind of want What? Oh, it's defaults. Alright. So if we go into here and figure out where we are, Codecrafters. Yeah, that's what we're doing, aren't we? We're doing a little bit of a tiki tour. But we've said it's that type. Alright. It can be an X, thanks. And what good lot you are. And is that kind of what I'm expecting? So it is the final block, that's what I knew, and B-type is 2, and that is also kind of what I knew. So because it is 2, I think yeah, so I guess here we can do maybe a switch. Maybe we can do an assert that B type is less than equal to 0x. We can't do that in this, can we? No highlighting, so I'm assuming no. Right, so I kind of want to assert that is we can have 0, 1, 2, or 3. So just make sure that that is the case. And if we do a switch on B type, so if it is, I feel like this should be a type F E num, and this can be types, so no compression, deflate, no compression, and what is our next thing? Fixed compression, fixed, and this can be dynamic, and what is this? This is deflate T, let's just call it that type thing, and we can probably have it as that. Wow. Deflate T that. Yeah. And then we can have some more stuff like that. Well, so here I kind of want to just get these and we can do a case that and that, and I kind of want to do an unreachable, right, so none of these are done, but this is unreachable. It's not meant to happen. And so unreachable can be unreachable, and not much more of a message. Just saying that shouldn't be getting there. And it'll spell out the thing, and you go here and you're like, alright, that's what's happened. So if I did that now, it goes to a point where we're getting like core dumped, and I wonder if that is because we do this unimplemented. Do we need to do a flush std here before we do any aborts? Except not for the info actually. No aborting there. So now we are in unimplemented there. So I guess unimplemented, could we take some sort of an error message? We're just, I think I could do that. So in this function, what haven't we done? And it is that what we haven't done. That has some things. What if we just pass in nothing? What if we just want to say that we haven't done? I think I can just do that. It takes a bit of time to do that board, but yeah, so we unimplemented on this line here in the dynamic compression. That's easy. So what do I want to do in the this one? we want to get these bits and whatnot. I wonder if I do something like this. So it'll be a bit of a pain doing that, but yeah, I think this is what I want. And then that's just unreachable. Then so that's what we called it. And we did that a couple of times, and this was no, and this was fixed. Right, and now if we did that again, so we can't do all of that. Right, so this is what I want. Did we now? Right, so it gets to the point that we there, and in here, what I want to do is int th is going to be bitstream the next bits, and we're going to get 5 of them. And here we're going to have dist, and that's going to also be 5. And here we're going to have hclen, and that's just going to be the 4. Maybe I'll do dynamic Huffman code, and then we can pass in all the things. hlit is that, dist is that, and hclen is that, and then these ones hlit, hdist, and hclen. So we can just see what's happening in this. So 18, 10, and 7, and is that what we got from here? 18 and 10, and only got 15, but I wonder if that's because because that is I really would like the bit thing, but I don't know. You gotta give 2 flags, one to make that happen. Right, so 1010, so that is going to be this one. It's So then 0111. I think it's that, yeah, so golly. Yeah, because we get the 2 bytes, so we're looking at this, so then we get 3 bits. So those 3 there, and then 1010, 1010, which got us 18, and then 0101, 01010. So after those 3 bits, we got 5, and then we got 1, 2, 3, 4, 5. We got another 5, and then we should get 0111, and I suppose that's getting it in the wrong order. Maybe it's the right order. So if it is the wrong order, it would, when we did this sort of thing, you would do something like 8 minus this, and it's potential that because we've been working with palindromes, no, see now it wants that to be a fixed compression, but I'm pretty sure that it is the dynamic one, and I must have just got this 15 the wrong way round. I kind of want to see what bits are coming out. So in this, we can go infer bit stream next, and we are returning D. Our index equals that, and our size equals that, and I think we can get away with that, and then we can pass in our ret, we can pass in our index and pass in our size and see what's happening with that. Cool, so that's now doing a few more things. So that got us that 1110, then 1. Maybe I want to also in bitstream next bits. We can just say that. Do we not like that? Because it's a 64. Probably told me somewhere in the message. Cool, so now we can kind of see what's happening here, and it is still just getting that 0111, and so each time it gets 1, that should get that 0, then shift it on. So I mean that kind of makes sense, and this 18 just seems, I don't know, maybe I got it wrong. Right, so now we have like a bunch of code links and stuff. in like a weird order. So we want to have this is going to be a code length, and this can equal to, and I believe this will like just magically work out what it is. No, we put that here. So we're going to have 19 things here. So index 0 will be one of them. Index 18 will be the top one. So this can just equal to that to start with. And I kind of want to make an assertion, maybe not here, but maybe in here. I want to make an assertion that HC len plus 4 is less than 19. I think that's what I want to say. Maybe that's what I want to say. So if there were 0 things, the array would be 0 size, and we would want to make sure that the number of things that we're going to read is 0. If there's, say, 1, then the number of things that we want to read. I keep on hitting the wrong number. Search for that maybe. I don't think I want that one. Right, so because of that, we're about to do a loop. So this is going to be HC len plus 4. Maybe it is equal, and I plus plus. Right, and then in this loop we were going to read a few more codes. So I kind of, there's like a particular order. In fact, they even give us the order that could potentially copy and paste. So is this what I need to do? And it will just magically do the trick. And I think I do like, do we have like a C array len? Define C array len, and golly, what is this? So of the array, this is going to be the size of the array divided by the size of the first element of the array, and do that. So I think that is kind of what I want to do. And and so then we would probably want to do an assert that C array len of order equals C array len of code length. So they should both equal to that. And now that I've got that, can kind of put that check in there. Cool, so at this point here, now we can read in code lengths of, say, order of I. That should be what we're wanting to read, and this will just be bitstream next bits stream and just 3 bits. And so like maybe now I want to kind of print out all the things that we kind of have. Info, printing code links, and this is going to print out all the code links. So this is maybe I'll just do something as simple as that, and this is just going to be I and code lengths I, and that doesn't quite work. Int and long signed int. That's all good. We can make U a size T and U a size T. Actually, this can go all C array lengths of code lengths, print them all, thanks. Sure. Right, so now if we have a look-see at that, it reads in some stuff, and there are some zeros and some more zeros. Right, so at now this point, we should have this many code lengths, but they're encoded using the code length Huffman code. So I guess that kind of means that for the first one, we know that it is 6 bits. Is this the one we want to do? We would like get 6 bits, and we can kind of see where it kind of starts and ends. Or is it just this one? Alphabet for the code links is as this, and we're getting the code links for the literal length. Yeah, so this is using the code length Huffman code. Which is this thing here. Now I'm kind of wondering whether I think what I need to do now is construct the code using this algorithm. Yeah, 3.2.2. That kind of did. So the Huffman code for an alphabet, we just know the code length. Easy. Code links are initially in. Right, so we have the code links. This kind of right, and then we count number of codes for each code length, and so like quick eyeball, we've got a couple with 6, and we have 2 with 6, so we can kind of start with that. So BL6 is going to be 2, and numerical value of the smallest code for each code length. So that like, I don't know, should I like just start kind of making this up? So this is kind of I don't know, I kind of want to put this up here maybe, type def, and this is going to be a struct, and what are we going to build? Huffman tree, and so this tree, does it kind of tell us what it is, what it has in it? It does not. So it seems to have a length in a code. So u int 8t length. Well, like maybe we'll call it a 64, and maybe the same thing here. We'll say it's got that many. Who knows? So in this one, so once we have all the code links, maybe if code links I equal to 0, we can continue, because that wasn't meant to be playing a part in things. And maybe because we were going to do things here, we might get a BL count. But like, how do we? Size t max length equals 0, and max length equals code length I max. If we do that, do we have you're just in the and then like macros. Interesting. I think I just want to do max length is less than code length I, then it will be that, otherwise it will just be max length. In fact, I think I want to do that. got to do a lot of like boilerplate. So now that we have the max lamb, we can make a even HTBL count, and this can be calc. So not member size. We're going to have one member. Well, no, we're actually going to have. Do we want that? I don't know how big they'll get. No, they can only, because we've only got 19 code links, we can only have up to that many things in that. But the number of codes of length of a certain value, and the length can be up to 7. So this is really like we can have that. I think that's what I want. Can only have like 8 values in the count, and we'll 0 initialize it. So we don't need to get the max code, but perhaps we can also kind of get this, so we can BL count and code lengths of I, and we can just do that, and we could probably make a cheeky assertion that code lengths I is less than C array length of BL count, which I believe it should be, but it may not. Otherwise, we'll do the print. So we have to like do some right. So I think I want that one maybe to go away. Right, so we're doing this Huffman code. So once we get the code lengths, we could probably show the counts. Perhaps now that we're like implementing things, so this is RFC 1951 3.2.2. Step 1. This is step 1. Alright, and then step 2 is down here. Maybe we don't print off the stuff, but we'll maybe we'll have it. But now we want to just do BL count. Cool. So this step that we would have it unit 64T code equals 0. We probably just need an 8, I don't know. And we would have BL count 0 equals 0, and then for now what's max bits? Is max bits like just the max length? I feel like that is max length. Yeah, only really defines it then. But I think it is just the max. Surely it's just the max. Maybe we can even call it max bits, and we can set it to that. And if code length I is greater than max bits, we can max bits equal code length I. Cool. And then we can have something like this, code plus BL count bits minus 1. And what's this next code? Is that just used here? That does seem to be used there. So uint ht next code, and this is going to have at least the max of that, which we decided was probably 8 there. Can hear a ringtone, but it's not mine. There we go. Hello, and welcome back. Just try and work out where I was. Cool, so this is doing that, and I think I want to do a similar print out of what our next codes kind of ended up. Maybe next code I equals that. I don't know what format I want. Code links. Do that. And here we can say this is actually next code. And like maybe see what that kind of comes up with. So that needs to be an L, that's alright. So this got a bunch of next codes, and so because this is a kind of code, I might put it as hex, and maybe do it a 2 and maybe do a 0x. And so that's just the code length. Decimal is probably better for that for me. Alright, so then that's kind of getting the next code. Cool, so now we do step 3. Different windows doing different things. So we want to come down here and get step 3. We can just do this print here actually. Well, when will it set bits 0? So I think I want this to be equal to max bits, and maybe this can be 9 things there, and maybe I want to do a certain max bits is less than equal to the array length of next code. So if it is equal to it, then we would have this count here, and we'll try and do some things. So I think that is the one I want, and we probably want to make sure that this is also less than equal to BL count. So it can be one more of that because it takes one less. Right, and then that just does that. So now we don't bother printing that first one. Now, did it, yeah, so we had 0612, and then we have 0612. So we're not printing the very first one. We could, I guess, but yeah, I don't know when the next code kind of gets set. Some stuff down here. Are we only taking in being one based? I feel like we are. Maybe, I don't know. That kind of makes sense. Right, so now we're doing this step 3. So maybe go here. So, I mean, we can do like a cheeky copy. We'll just do this copy. We probably have to implement some things. It says the n equals 0, n is this was the max code, so I guess we need to kind of keep track of max code, and this can be equal to that, and here I guess if code is greater than max and then max code equals code, maybe throw it around, that sort of thing. So we're trying to work out a similar thing. So here we want max code to be equal there, and so that means here we need to have like a bunch of things. So the max code is well, I wonder what max code is. Max code is yeah, do that and do that and just do that, because I wonder, so it's like 94. So how big do we need to have this tree kind of a thing? It kind of does describe that we can so there are better ways of doing this and constructing a tree than like going left, right. So I guess the right, so I need to have like a bunch of tree things, and we're kind of keeping everything in bytes. So the max code was just that, but the bits was going to be that, and the max bits was just going to be the max length, and the lengths were all just 3-bit numbers. So this should be getting, I could add on like quite a bit. So what I'm currently thinking is, like, I wonder if this is overflowing, to be honest. Like if we made this 60, sure, make this a 64, and we can make that a 64, and I guess here this would be like that. I think that might want me to do that, and here it probably wants me to do that. And I just want to kind of see if it overflows out of that. Yeah, so it does go over a single byte. So I guess here is where we like allocate the tree. So we had a type, Huffman type. So this can be a pointer, and we can make it calloc, and the number of members is this n, which is max code, but it's actually max code plus 1 because it goes from 0 up until inclusive of max code, and the size of this is going to be the size of a Huffman tree. So if this tree equal null, then we probably want to return null. So I think at this point I now know that the return of this is probably going to be a Huffman tree and a pointer to it. And so I guess here we would probably just return that tree, but we're like unimplemented beforehand. I think that's alright doing that. So this is probably going to, wow, we're going to get a Huffman tree. That's alright. We start off, so code links are initially in tree up until that, and the codes produced are there. I love how they use like so many different things. So we knew how many things like we're gonna have. It's not this one. I think it's meaning this. But yeah, we're going to be reading some things. But after like building a tree, right. So to start with, I guess the tree in we need to kind of set to be something. So the max code. Assign numerical values to all codes using that. So we need to get the original length. Code links are initially all in there, but like how big is this thing that we're meant to be getting? We only find out until later, but we have like certain number of that. What do we know about these code links for all of these things? Yeah, it just seems kind of weird that max code is 112C, but the code links array is 9. So the code links is 19, well under this max code. So this next code, I wonder if we're meant to be wrapping it. It just doesn't quite make sense to me. Because, yeah, okay, so we get the length, but the length is based on that. And I'm just wondering, 0x12C, it's 300, that didn't kind of show up in things there, because how many were we meant to read? HC lit plus 257, so what's 18, Python 18 plus 257 is 275, but then we have HDist, and there'll be like another 11, plus 11, it's not the, it's not what I kind of thought. Right, so yeah, I guess I'm now kind of stuck with what the initial length is meant to be based on all of that, and I wonder if I'm going down the wrong kind of hole, but I mean, this is kind of what I've had. So we get 5 bits, we get 4 bits, and then we get a bunch of links, but we get 19 of them, and they fit in the range 0 to 7. Cool. And then we get like a lot of code links that are encoded using the code length Huffman code. So we kind of need to build this Huffman code, and it describes that each code described is defined by a sequence of code lengths as discussed in 3.2.2. And that is just saying that the code link sequences themselves are compressed using a Huffman code. The alphabet for the code links is as follows. So, like, might have to do something interesting here. And the 3.2.2 is kind of talks through things here. Yeah, the code links are initially in that big there, and the code's produced in that. So I wonder if this tree has to be just, I got it, this max code is not what I thought it was. So I think so the max code, which we can I wonder whether this is whether we care that overflows. I think I'll do that. But the max code we don't really want here. So we'll get rid of that, and the max code happens all the way here, I think. And here I kind of want to make this a uint t code len, and then that thing equals code len, and if code len is greater than 0, then we want to set this to be just I. It's going to be in this weird order. But we're going through the code lengths. No, so I kind of want this to be order of I is greater than max code, then this we want to be order of I, just because it reads it in a weird thing. And here we got a max code, so we can probably like print it there, and maybe we can set this to be some things. Let's do that. Don't do that. Just let me run it. Right, so max code will get printed up there, and now that looks a little better. So we could perhaps even just go back to calling it a decimal. Right, so max code is 18, and happens to be the same as hlit, which kind of makes sense. Does it? I think that might make sense. I don't know if it does, but we'll build this tree, but beforehand we'll kind of set the tree, we can call you I, because we call it that, and what do we call a Huffman tree? Huffman tree, we do just call you code. So the length was going to be what we already know. So the length is going to be code lengths of I. So that makes sense. And we should potentially do like a cheeky assert that order I is less than C array len of code lengths. It's not hitting at the moment, but just want to make sure that that's all right, because we do some funky things here. And we do that, so we create the tree, and once we have the tree we can kind of go through and add it, and then we do that. Now in the step 3, this is where we can perhaps do that step again. So here we would do U8T, we call it N here, N is less than equal to max code in plus plus. So the max code, I guess, is going to be equal to an order thing, which is going to be less than the code length. So that's all good, but we get +1 of them, so we can set all up to them. Right, so at this point here we can if xt len, so this is going to be tree n dot length, and if len is greater than 0, then we would do tree n dot code equals next code of len, and then next code len. That whole thing is going to plus plus. Is that what I'm reading there? And so this len is just a length, and that's a 7-digit number. Next code, that's easy. Next code was just the 9 bits. And then we add 1 to it. Cool. So, golly, what does this do? It gets us a tree. So I guess in deflate block we can say that we have now got a Huffman tree, and it is equal to this, and we probably want to do a free of that tree at the end, but for now we can have it, and like maybe we can do a little print of what it has. Huffman tree of dynamic compression, And so this should equal to like a bunch of things. For each of the tree will have, it doesn't really say the symbol, but we can kind of say the length in the code. I mean, that's kind of all we're kind of interested in. So we don't really have the size of the tree. So we have an array of a bunch of things, but we kind of maybe want to get 2 extras, so the last one will be null. So when we do that calloc, we can do +2, and we'll set a bunch of things, and when we get a length of 0, it means that we have no, because we could have a length of 0 there. I think I need to make Huffman tree is just a we kind of need to return a length as well as the Huffman tree. But like here we can have like well, we return a Huffman tree, but we can have wow. Here we can pass in our Huffman tree. So this is going to be a Huffman tree, and it is going to be a thing. And so the Huffman tree is going to be a thing, but we're actually going to have an entry beforehand. And so the tree is actually just going to have a Huffman tree entry pointed to that, and we can have that being the data, and then we can have size t length, and we'll just have that. And that way we can calloc down here, and here we can go tree data equals this, and tree data, make sure that is that, and if that is the case, we probably want to just return. Otherwise we'll have tree size, is that what I called it? It was length. Length, and this is going to be max code +1, and that can be that. And then we only have to add in as much as we need, and here we can have tree data, that is going to be that, and then when do we next do tree, it's down here, and it's just going to be those 2 things. And here we've just built it, build tree. So this is going to build us a tree, build tree, and so I guess the Huffman tree, we can have it like that and give a pointer to it, and then for size t, I equals, and I is less than tree length, and I plus plus, and here we are going to just print out the print std error, and what do we want to say? We want to say tree of that, and it can equal dot length equals that, and dot code equals that, I guess. And do something like that. And maybe we can provide this with the eye and the tree. And this is just a dot data I, and this is a length in tree dot data I dot code. And at the end, we just want a free tree data. Does that kind of like things? Cool. This doesn't like it. A label can only be part of. If we did something like this, I think we'll be happy. Is that what it'll like? Yeah, so it'll be happy with that. We can give that sort of thing, and we can give that sort of thing, and cool. And if we do this again, we're still getting unimplemented at the end, but we're printing out a tree, and who knows if this is right. Just heard a weird noise next door, but it could either be right or it could be wrong, and I wonder if this like longer length one is kind of interesting. And like these trees there, when they're zero, which, well, yeah, if they're zero, we just shouldn't get that. And right, so at which point here we I just don't know. So I've talked about it in the past. There's a possibility of just reading the source code. So it's released under like the zlib kind of license, and basically the origin of the software must not be misrepresented. I can't claim that I wrote the original stuff. I did not, and if I use this, I don't plan to use it, but I might plan to use just like bits and pieces of the source to be like, what's happening here. And I'm not planning on like just grabbing the source as is, but what I can do is, I think it was like in here, we can kind of see what happens when we kind of get the, is this just like, no, this isn't the, inflate, yeah, so if we start with inflate, we want to yeah, where's fixed tables get called from? Fixed table gets called from there and there. Right, so in this case we want this one here, the dynamic code blocks. Right, so this should get that, and it would drop bits too. And so this bits, how do we do it? Yeah, so that's getting the we do this need bits beforehand. So I do it a little differently. But yeah, so we get the dynamic one, then we drop bits, then we break. But we are in mode table, which there is a case for table. So we need to get so many things, and then we kind of set all the things. Don't think we need this. So I guess that's, well, I mean, we can see what our kind of, I don't know where it like kind of warped me back to. So I want it to be in table and 898. 898. Right, so we get that many things, and right, our n len was that first one, so 256, is that what we are? 257 is what they're adding, so this 18 plus 257 is gosh, and kind of right, so Python 18 plus 257, and that's 275, so it is less than that. And indist, which was the next one, would be 11, so that is also that. So I think the sizes are okay, and so then we fall through into lens. So we encode, we kind of set that. So we're now doing this looping for 7, and in fact, like hc len, hc len. It's kind of weird that they call it nlen and ndist and encode here, but then in the actual RFC, which this is meant to be a reference implementation of, uses different things. It is what it is. It is what it is. So encode was the last one. So 7, we would be reading 9 things. That kind of makes sense. We are reading those 9 bits. And right, so they do a similar thing with the order table, which I assume this would have kind of said that these are the orders, and that is kind of the orders. I just copy pasted them, and there's 19 of them. Perfect. Lens. So that is just setting the remainder to 0. We've already kind of done that with just the way we build tree. Right, yeah, when we create it, we 0 initialize with that. So it should be 0 after this point, is my understanding. And then, so we can just kind of read just that number, and the rest will still be 0, which potentially is right. Hard to know. Right, and then next is going to be codes. And what was codes? when do we set codes? I guess this is just set to nothing to start with. So on this thing here, we should have codes. Is it hiding under here? Yes, we have codes enough. I love it. Enough is just enough len and enough dis. Crazy. Right, so we have enough codes, which could be a big number. And that's just the same as that. We can do like an inflate table there, so what's this codes? Is this what I want? No, this isn't what I want. Maybe it was what I want. Inflate table is what I secretly want, and definitions. Yeah, so this one here, and see, it's not meant to be using that stuff yet, I thought. And max bits, that's already got set. Right, so that looks like it's doing maybe some things. I don't know. Maybe I'll have to come back to this one, but it's a little odd. I mean, I could kind of compile this and like put in debug statements just to say what's what. Because I'll be interested in kind of my thing, because I believe if we objects so this is like zlib, so if we like cat that to zcat, I think we'll pardon me. How do we just do it with is it just that? But like, is that what I think it? Nah, that's that. Right, so man is the lib. What can we? I know I've got a thing to do, but like, is there a like some examples? That'd be good. So in that zlib in this, so we see look examples, but I kind of don't want example as well. Like, what if we configured this? Hopefully I have everything to build it. This has everything I need to build by the looks. And so now do we have like a compare find minus type E executable, but like where we are, that is kind of where we are, but like not a directory. It would be kind of good if you weren't showing all the directories. Type D, something like this. So we have example, these two examples, that could be what I want, and this example as well. So example, and this does like a big one, alright. And is that, no, that's like not a SH script. So how did they get kind of built? What is Z pipe? Is that kind of what I might want to do? Z pipe. Do we just have to build you? zlib. I don't know. Package config libs and C flags of Z. Yeah. LZ, of course. Right, so if we just did that, we should get an A.out. And is this kind of what we need? If we like cat source person or publish, no, we don't do that. Codecrafters, and this was in our Git, and if we looked at our Git objects, and it was like 7.8 something. Yeah. And we can confirm that 7.8. Yeah. So this looks like it has a bunch of things, and if we did something like that, what does that give us? It doesn't. what I thought. Maybe I should read that z pipe. No, z pipe. Alright, main, how do you get called? We had binary, so we're just dumping it to that. And compression if no arguments, so we want to do decompression minus d. So what happens if I do this minus that? Yeah, so that looks perfect. That is what we're kind of meant to be seeing eventually. But yeah, I guess if I have it to a point that I can do that, and like I wonder if I can like when I did the GCC with this, I wonder if I can do something like I can replace my current zlib, but like I've just built a bunch more. So if I look here, there is this guy here. I could kind of include that in. So I wonder if instead of doing that, I can do yeah, so I can do that, and then that's just doing that, and we can where was this thing in vim of inflate, and if we look for lens, we can see here. So maybe we could trace v. And how do you get called like one of these two? I can't actually see what's down there. So trace v if z verbose. You know what, I'm just going to do a printf std error state, like almost what I could do is do this do this and try and so it has like a bunch of things. I kind of want to so this we can minus ggb minus g, and maybe the same there. And if we make that again, so this will have debugging symbols for all the things that I want. And if we look at examples again and do this, now we can do this cat of that and into that. But what we can do is maybe we can edit this whole thing, and I kind of want to this can be there, and args is going to be run like that, and this can be do that, and here we can go back here in GDB. Want to get that thing. We want EX that. Yeah, so here we want arbs, perhaps even after the EX, I don't know. Yeah, so it doesn't let us do that. So what if we cat this file? What if we cat that file and we can just move this. Cool. And move this to dot zlib. Even zlib, and maybe remove that old one, and then here we can go gdb arbs a dot out minus d, and now we can go run and maybe even just imp dot zlib. But now we probably have to do something like this. Yeah, cool. So now we have got to some points. We can probably go break on the lib/inflate inflate.c. And can we go like 917? Right, so what if we do break on main? Yeah, right. Well, let's restart it, because like, who knows where it is. Like, I want to just fin from there. Cool. And then I want to step into this one. Right, so we do this. We do an inflate. Have we just already finished? Alright. Yeah, sure. We have 18 available bytes. Right, so at this point here it didn't let me step into it. with debug info. Alright, so if you had debug info, why on earth can't I run -t and imp do that thing? So yeah, no source available. How do we get the source available in that? I think I'm kind of running down a rabbit hole that doesn't need to be run down. But yeah, I think that's potentially the realm I'm going to go. I feel confident that I'm not a lawyer, but I feel like me reading the source code just to get an idea of what bits are where is legitimate use of that software under that license. I mean the license is pretty free anyhow, but I'm not planning on taking the data. I would rather just take it from the RFC, but it is what it is. So yeah, I guess that's that. And I'll leave it there and see where I get up to. And until next time, we'll see ya.